Hi everyone, today we're going to be investigating the nature of the roots. So basically this is determining how many possible x-intercepts a parabola could have. So we could have two x-intercepts, or in other words, two roots, or two zeros. So we could have a parabola that opens up and our x-intercepts are there, or we could have a parabola that opens down and we have two x-intercepts there. So that's just an example. Or we could have one x-intercept or root. And we also say that they are real roots. They're part of the real number system. Okay, so in this case, that means our vertex and our x-intercept are the same. So we could have a parabola that opens up right on the x-axis or a parabola that opens down right on the x-axis. The third possibility is that we have no real roots. So zero real roots or zero x-intercepts. So I could have a parabola that opens up and it's above the x-axis, or a parabola that opens down and it's below the x-axis. Okay, so we can use the discriminant to determine how many real number solutions a quadratic equation has, or in other words, that's the number of zeros or x-intercepts or roots. Okay, so these words are all used interchangeably. Oops. The discriminant is the value of the part that's underneath the square root in the quadratic formula. So that's the b squared minus 4ac part. Okay, so let's take a look at our possibilities here. So if the discriminant, so b squared minus 4ac, if it's greater than 0, that means we have two real, distinct, or different roots. So in other words, we have two x-intercepts. If the discriminant, b squared minus 4ac, is equal to 0, we have one real root. Or in other words, one x-intercept. And then if the discriminant, b squared minus 4ac, is less than 0, we have no real roots. So in other words, we have zero x-intercepts. Okay, so let's look at an example. So a, b, and c. So b squared minus 4ac. So negative 3 minus 4 times negative 2 times negative 5. So this simplifies to 9 minus 40, which is negative 31, and that is less than 0. So since our discriminant is less than 0, we can conclude that we have no real roots. And this makes sense, right? Because this is the part that's underneath the square root when we're trying to figure out the quadratic formula, and I can't take the square root of a negative number. Okay, let's look at another example. Oh, to be continued. Let me see if I have another one here. 2x squared minus x minus 6. Okay, so a, b, and c. So b squared minus 4ac. So negative 1 minus 4 times 2 times negative 6. So that's 1 plus, let's see here, 8 times negative 6 is 48. So that's 49. And that is greater than 0. So therefore we have two real, distinct roots. Okay, I'm going to see if I can squeeze another example on the slide because I don't have any more slides after this. Okay, so we'll call this example 2, and this is example 3. So x squared minus 10x equals negative 25. So I'm going to bring the 25 back over. So x squared minus 10x plus 25 equals 0. So A, B, and C. So we have negative 10 squared, so b squared, minus 4 times 1 times 25. So 100 minus 100 equals 0. So since our discriminant equals 0, we would conclude that we have one real root. Okay, that's it for this lesson.